Hello, I'm Hao Zai from School of Mining Engineering. My research topic is determination of weak rock mass properties from laboratory tests. Why is this important? Because we still don't have a practical means of determining the properties of weak rock mass, although it's a very common type of rock we will encounter in the field. So if we consider weak rock is a transitional material between hard rock and soft soil, weak rock mass behavior should converge to the hard soil, hard rock at its upper bound and soil at its lower bound. For soil, the laboratory properties can be used directly in the field, but for rock, the laboratory properties need to be downgraded first due to the existence of discontinuities. Then there's a dilemma for estimation the strength of weak rock mass. Let's explain this dilemma with an example. If we have a clay stone with a UCS of 8 MPa and 3 joint sets all in good condition, the estimated rock mass UCS is approximately 0.8 MPa when applying the currently available rock mass downgrading methods. This strength roughly equals to the strength of some hard clay. Intuitively, we know there's an underestimation of weak rock mass strength. As implied by its name, soft rock has relatively low binding strength, although among small mineral particles. Therefore, it cannot withstand very high compressive strength as harder rocks. A key argument extended from these basic properties is the role of the discontinuities for soft rocks. Classic downgrading system assumes that the rock mass behavior is mainly controlled by the discontinuity networks, and failures always occur along the pre-existing defect planes or through small bridges between two adjacent discontinuities. This assumption is valid and reasonable for hard rock, but not necessarily valid for soft rock. The strength differences between rock matrix and discontinuities diminishes as rock strength decreases. For the extreme case where the material is just a pile of cohesionless sand, the existence of discontinuities can only marginally reduce the mass strength as there is very little differences between intact material and discontinuities. Hence, the failure are equally likely to occur on both intact and the fractured component of sand. Based on this argument, it's reasonable to postulate that less the discontinuity-based strength penalty should be applied to soft rocks. So my task is pretty simple. Firstly, I need to verify the downgrading level through numerical modeling and back analysis of slope failure cases. Then I need to develop a weak rock classification system that could group rock mass according to their qualities. And finally, I need to establish a relationship between laboratory properties and the field properties based on the weak rock mass classification system and the numerical and empirical calibrations. At the current stage, my aim is to collect as much slope failure cases as possible from mine sites and from literature reviews, and conduct the initial verification of hypotheses through UDAC numerical modeling.